Hello children, let us start 10th class sets. So before going to do that, let me have a small talk about the proverb which I have selected today. The proverb is, don't only watch the time, do like it. What is the meaning of this, children? Don't only watch the time. Means usually we, for any work, we say what is the time now, or how long I have worked, how much time I should do it, or so many ways. You find out about the time. You do everything basing on the time only. Your examinations, 2.5 hours time, you have to complete it. So we always, every one of us, keeping on watching the time. But the proverb says, don't only watch the time, do like it. What is the meaning of it, children? Have you ever had this kind of thought, children? What does watch do? Of course it gives us time, but it works continuously. There is no time when it stops. Endlessly, effortlessly, it keeps on doing its work. So it will not say that I am vexed, or it will not say that I am tired. It will not stop for it. Continuously it does its job. You have to do like that. That means what, children? We also must fulfill our tasks without any boredom, without any effort. Effortlessly we have to work. We have to have that kind of joy in doing our work. Okay, children, if you feel that joy, definitely you love to do your work and you will get success in it. Let us come back to our studies. In the sets, the last topic which we are going to talk about is finite sets. Finite and infinite. Finite and infinite sets. We are going to talk about this. So first, let me talk about finite sets. What is a finite set? A set in which it is possible to express all of its elements is called a finite set. This is the definition of a finite set. A set in which it is possible to express all its elements. So for example, you have got a x such that x is a set of even prime numbers. So x is a set of even prime numbers. That means what, children? You have only 2. So it is possible to write that here. So we call that it is a finite set. So any type of set in which we can write all the elements possibly, that set is called finite set. I hope you have understood, children. Write down this, children. This definition you write down along with the example. Now we will go to infinite sets. The next one is infinite sets. So a set in which it is not possible. You have to only change here, children. It is not possible to express all its elements is called an infinite set. An infinite set. So when you say that X is a set of prime numbers. Only prime numbers. Then what you will write, children? Prime numbers means 2, 3, 5, 7, 11, so on. Can you end it? Can you write all the elements? No, it is not possible. So we call it as an infinite set. It is an infinite set. So write down this, children. This is infinite set. Infinite set means it is not possible to express all its elements. That is called as infinite sets. That was an example. So I hope you have understood. Now let us see what else are given here. Now you have got example 13. Example 13. In this example 13, you have to find out which are finite and which are not finite. So, state which are finite or infinite. You have to find out which of them are finite or infinite. The first one is x such that x belongs to natural number and x minus 1 into x minus 2 is equal to 0. So see, children, if you consider x minus 1 is equal to 0, then x is equal to 1. If you consider x minus 2 is equal to 0, then x is equal to 2. Therefore, what is the set? The set is 1, 2. So you are able to write the elements. So what you will say? It is a finite set. So you can express it as a finite set. Right. Next, let us see the second bit. Second bit, x such that x belongs to natural number and x square is equal to 4. When x square is equal to 4, what is x, children? X is root 4. X is root 4 means x is plus or minus 2. But x belongs to natural number. Therefore, we have to take x is equal to 2. We cannot take minus 2 because minus 2 is an integer. We are not supposed to take. Therefore, what is the set? The set is only one element 2. So, what you will say, children? It is finite set. It is a finite set. You can write the element properly. So, you call it as a finite set. Write down. Now, third bit. What is the third bit? Third bit is x such that x belongs to n and 2x minus 2 is equal to 0. So, if you consider 2x minus 2 is equal to 0, what is 2x, children? It is 2. X is equal to 2 by 2, that is 1. Therefore, what is the set? The set is 1. So, you are able to mention the element. So, it is a finite set. This is third bit. Now, fourth bit. Fourth bit, x such that x belongs to n and x is a prime. If x is a prime, what is the set? The set is prime numbers 2, 3, 5, 7, 11, so on. Can you end it? You cannot end. So we will say that it is an infinite set. You cannot end it, so we call it as an infinite set. Next, copy children. Now, fifth bit, x such that x belongs to natural number and x is odd. So what is the set? The set is odd numbers 1, 3, 5, 7, 9, so on. You cannot end it. So what you will say? What can you say here, children? It is an infinite set. It is an infinite set. So I hope you have understood, children. This is, copy it. This is example 30. Now, let us see what is the next part. Next one is cardinality of a finite set. Cardinality of a finite set. Now, what is this cardinality means? The cardinality will say that the number of elements present in a set. Actually, the set should be finite set. In a finite set is called cardinality of the given set. It is also called as cardinal number. Cardinality is also called cardinal number. Let me take an example. Set A is equal to 1, 2, 3, 4. So, n of A we call cardinal number. N of A, number of elements in A. 1, 2, 3, 4 are there. So, 4 is the cardinal number. Now, let me take another example. B is equal to P, Q, R. Number of elements in B. How many? 1, 2, 3. So, this is the cardinal number. So, cardinal number means what, children? It is nothing but you are counting how many number of elements are there in the given set. That you are writing. That itself is called cardinal number. It is represented like this, n of. So, I hope you have understood, children, about this cardinality. Copy this. Now, what is the next one? Let us see. Do these sums are there, children. Let us see what are the do these sums. First bit. State which are infinite or finite. Finite or infinite. Give reasons. State which are finite or infinite. You are going to state it with the reason. Let us see the first one. A is equal to x such that x belongs to natural number and x is less than 100. What do you mean by this? You can write the elements, children. 1, 2, 3, 4, so on up to 99. So, we can represent all the elements of the given set. All the elements you can represent. Therefore, it is a finite set. You can write it as a finite set. Let us see the second bit. What is the second bit? Second bit is P is equal to x such that x belongs to natural number, x is less than equal to 5. X value is less than equal to 5. So, B is equal to, natural number starts with 1, 1, 2, 3, 4. Because of equality, I should write 5 also. So, here what you can represent? We can represent all the elements. Therefore, it is a finite set. So, these two problems, children, write down. Now, the next third bit. Third bit is C is equal to 1 square, 2 square, 3 square, so on. So, we cannot represent all the elements. Why, children? Because of these dots. Therefore, we will say that it is an infinite set. It is an infinite set. This is the third bit, and fourth bit, D is equal to 1, 2, 3, 4. So, here all the elements are represented. Therefore, it is a finite set. So, only the thing you have to see, children, whether it is possible to write all the elements or not. If it is possible, it is a finite set. If it is not possible, it is an infinite set. So, I hope you have understood, children. Now, fifth bit. X is such that X is a day of the week. A day of the week means what you will write, children? You will write Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. So you are able to write all the elements. All the elements can be represented. You can represent all the elements. Therefore, it is a finite set. Okay, children? Write down this. So first problem of this, do this is completed. Now we will go to the second problem. Tick the set which is infinite. Tick the set which is infinite. This is the question. What is the first one, children? The set of whole numbers less than 10. What you will write, children? Whole numbers 0, 1, 2, 3, so on up to 9. So you will call it as a finite set, because you need not worry about writing the other elements of this. Directly you can write all the elements. Second one, the set of prime numbers less than 10. So what are the, children? 2, 3, 5, 7, that's all. So you are able to find. So it is also a finite set. And these are all A, B, C he has told. So this is about A, this is B. Now what is C, children? The set of integers less than 10. Here you see, children, integers means less than 10, 0, 1, 2, 3. So on less than 10 means up to 9 we can write. But here minus 1, minus 2, it goes on like this. You cannot end it. Less than 10, all the negative values. Here positive you can write up to 9. But negative it goes. So it is infinite. You cannot end it. Next. Now D bit, children. D bit is set of factors of 10. So what are the factors of 10? Factors of 10 is equal to 1 into 10, 2 into 5. So what is the set? You can write set as 1, 2, 5, 10. So you can write them. All the elements you can write. So we will say that it is a finite set. So in this, what is the answer, children? Which one you have to take? You have which is infinite. So only C1 is infinite. So C is your answer. So take it, children. Now the next part of it is exercise 2.4. In exercise 2.4, the first one you have to state which are empty or not empty sets. You have to represent it, whether it is an empty set or not an empty set. First, set of lines passing through a given point. Lines passing through a given point. What is this, children? Suppose you have got a point. How many lines you can draw through them? A point is there means you can draw any number of lines like this. No and for them. You can draw any number of lines through that point. So it is not an empty set. Not empty set. You can write the elements. So what is the second one? Set of odd natural numbers. Odd natural numbers divisible by 2. Divisible by 2. You know children, only even numbers are divisible by 2. When you divide a number by 2, you will get 0 only for even numbers. Odd natural numbers, when you are dividing by 2, you are getting remainder as 1. So, here no odd number will be divisible by 2. So, it is an empty set. It is an empty set. Write here capital. Next, the third one. X is such that X is a natural number, and what is it? X is less than 5 and X is greater than 7. So children, if you draw a number line like this, 0, minus 1, minus 2, minus 3, it goes on like this. 1, 2, 3, 4, 5, 6, 7. It goes on like this. 8, 9, 10. Less than 5 they are saying. Less than 5 means, see, the numbers will be in this direction. Greater than 7, the numbers will be in this direction. Is there any common element for them? No. So, we call it is an empty set. No elements are common here. So, it is an empty set. So, copy this children. Now, fourth one I will do. Fourth bit, a set of common point to any two parallel lines. Common point to any two parallel lines. What are parallel lines, children? Parallel lines will be drawn like this, saying that the distance between the parallel lines is always same. When the distances between them is always same, where is the question of joining them? They will never cross. So you don't get any elements there. So an empty set it is. It is an empty set. Next, fifth bit. What is the fifth bit? Set of even prime numbers. Even prime number. Even prime number, of course, 2 is an even prime number. One element is there. So it is not an empty set. So these are the solutions for this children. Write out. I will go to the second problem. The second problem is, state which of them are finite or infinite. Which are finite, which are infinite, you have to say. First one, months of an year. Months of an year. Months of a year, not a, months of an year. It is a finite set because you can write all the months. So it is a finite set. And second one, 1, 2, 3, so on up to 99, 100. So here also you have got n element. You can write all these elements. So this is also a finite set. Third bit. Letters in English alphabet. Letters in English alphabet. Letters in English alphabet, definitely you can write all the letters. So it is a finite set. Now, fourth one. Oh, this is a fourth bit, children. Sorry, this is fourth bit. And I should write the third bit. Third bit is a set of prime numbers smaller than prime numbers smaller than 99. Of course, you can write them after before smaller than 99. So you will say that it is also a finite set. Now, what is the fifth one? Set of lines that can be drawn parallel to x-axis. Parallel to x-axis. Parallel to x-axis, innumerable number of lines you can draw, children. It is infinite. Because on the coordinate axis, this is x-axis. How many parallel lines you can draw, children? Countless parallel lines you can draw. So it is infinite set. Next. Sixth one. Numbers which are multiples of 5. Multiples of 5, this is also infinite. Okay, you cannot count. Now the seventh one, this is circles passing through origin. Circles passing through origin. Origin means 0, 0 on coordinate axis. How many, children? Infinite. You can draw infinite number of circles over there. So this is the second bit, children. With this exercise is completed. Please copy. Now you have got one more example, that is example 40. What does this example 14 says? If A is equal to 1, 2, 3, 4, 5, B is equal to 2, 4, 6, 8, you have to find n of A union B. Number of elements in A union B. First you write what is A union B, children. Long back we have done 1, 2, 3, 4, 5 A set, union B set, 2, 4, 6, 8. So union means what, children? All elements will be writing, but repeated ones only once will write. 1, 2, 1, 2, 3, 4, 5, already 2, 4 we have written, 6 and 8. Now the question is n of A union B. That means what? Number of elements. How many? 1, 2, 3, 4, 5, 6, 7. So 7 is your answer. A union B has got 7 elements. So I hope you have understood, children. With this, I am stopping you. Just copy it, children, first. Now we will go to the next chapter. Chapter is completed.